Hi, Miss Marion here. We are doing Unit 3, Lesson 5. What you need to do is turn back to page 135. You need to read the I can statement. I can find the rate of a change of a linear relationship by figuring out the slope of a line presented in the relationship. So give yourself a number. 1, a sentence and how you feel about that. And then a number. 1, I don't remember. 2, I kind of remember. 3, I remember, but don't ask me to teach it. And then 4, I do know how to do it, and I can teach it to my friend. So go ahead and do that. Alrighty then, we're going to go ahead and turn to page 45. On page 45, it says find the value of 2/5 divided by 1/2. Go ahead and pause for a second and figure out what that is. If you have found your answer, so we're going to do 2 5/8 divided by 1/2. Your answer should be 5 and 1/4. Okay. You can either do it in your calculator. You can also do it by hand. Right? Remember that when we divide by a fraction, we're actually multiplying by its reciprocal, so flipping times kind of stuff. And then we can kind of go from there. So your answer should be 5 and 1/4. So today what we're going to do is we're going to be talking about stacking stacks of cups, and then also how far they measure, how tall they measure. I guess you can kind of say that. So if we look at this picture here, we have 1, 2, 3, 4, 5, 6 cups. So if I stack 6 cups together, it's going to go ahead and be 15, and then this is centimeters is what we're dealing with. So it'll be 15 centimeters for 6 cups. So keep that in mind as far as we kind of work through what we are going to be doing today. So on page 46, we have this picture and some information. We have 2 stacks of styrofoam cups. One stack has 6 cups and its height is 15 centimeters. The other one has 12 cups and it's 23 centimeters. How many cups are needed for a stack with a height of 50 centimeters? So go ahead and work through this. You're going to have to pause and work through this and figure out how many cups that will be. Now, since you've kind of worked through it, let's talk about it together. I personally like to make tables out of the information that we have. So let's go ahead and make a table. So we have cups, and then we have height. And if we think back to it, let's figure out our independent and our dependent variable. The height is going to depend on how many cups that we have stacked. So the cups is X. Height is Y because it is the dependent. First piece of information is given to us. We have 6 cups, 15 centimeters. That's this stack here, right? So we have 6 cups, 15 centimeters. Sorry, my pen's being funny today. Second piece of information we have 12 cups, 23 centimeters. So 12 cups, 23 centimeters. And so we've been talking about the constant rate of proportionality. And so we've been doing 15 divided by 6. So that's that first number. If I do 15 divided by 6, that's going to be 2.5. So the other one is 23 divided by 12. If we do 23 divided by 12, that is about 1.9. So we can't do the same stuff that we've been doing in the last couple of lessons. This one is 2.5. This is 1.9. So there's kind of some fishy stuff going on here, but we can kind of look at it and go home. Okay, so if I have 6 cups and it gives me 15 centimeters, I add 6 more cups, it gives me 23, right? So let's add 6 more cups onto there. So we have 18 cups, right? And then how did it go from 15 to 23? Well, it added by 8, right? Okay, let's do that with the 23. Let's 23 plus 8, and we get 31 centimeters. All right. We can go ahead and kind of keep this going on as far as the different numbers. And I'm going to have to erase some stuff because I'm running out of room. So I'm going to go ahead and make my table longer. Okay. So 18 plus 6 is 24. 31 plus 8 is 39. Okay, we're trying to get to 50 centimeters. So we're trying to get the y to 50. So 24 plus 6 is 30. 39 plus 8 is 47. Ooh, we're almost there. Okay, so and then if I go ahead and I want to make it so it's 50. If I add 6 more, so let's say I do 36, 47 plus 8 is 55. What if I do half of that? Let's do 30 plus 3 is 33. And then let's do 47 plus half of the 8, which is 4. It brings you down to 51. So how many stacks, how many cups will it make so that it's 50 centimeters? Well, it's going to be like a little less than 33. But can you really have like partial of that cup? No. And so our number is actually 33. We're looking for that number 33. All right, so here's the table that we actually made looking at page 46. Notice how on the number of cups, we're adding by 6 all the way down. Notice with the height in centimeters, we are adding by 8. And if you don't have this table, you'll need this table on page 46. We're going to use it for page 47. So go ahead and pause, write it down if you need it. So here's a visual representation. If you want to go ahead and count all of those, we'll have about 33 cups to go ahead and make the 50 centimeters. So on page 47, number 1, if you didn't create your own graph of the situation before, do it now. So that's where that table comes into play. And so go ahead and pause, go ahead and make that table. Actually, make that graph. All right, what I have done, as you can kind of see, I took the table and I went ahead and plotted it on this graph. So you can see the 6, 15, 12, 23, 18, 31, 24, 39. And you can see where those things came from. Okay. So number 2, let's go ahead and answer number 2. All right, question number 2 says, what are some ways you can tell that the number of cups is not proportional to the height of the stack? Go ahead and pause and answer that question, and then we'll come back together. So one of the things as far as finding out if it's not proportional, if you look at the graph itself, this graph does not go through 0, 0. So it is not proportional because it does not go through 0, 0. We can also, as we did before when we were looking at the graph, when we were doing the 15 divided by 6, we got 2.5. We did 23 but divided by 12, we got 1.9. That also makes it so it's not proportional. Okay, so there's a couple of things that we can go ahead and do to go ahead and find out that if it's proportional or not. Number 3, what is the slope of the line in your graph? What does the slope mean in this situation? Go ahead and pause right now and go ahead and find the slope. So the way that I like to go ahead and find the slope, we have a lot of points on here, and I like to make a slope triangle in between the 2 points, right? And I like to go ahead and find my vertical and my horizontal on that slope triangle itself. So my vertical would be 23 minus 15, that is 8. So my horizontal is 12 minus 6, which is 6. So this slope is the vertical over horizontal. Okay, so remember that's our slope, and it will be 8 over 6. We can reduce that down because that's a fat fraction. We want to reduce it down to 4 over 3. So what does the 4 over 3 mean? If we actually if we label it how it is, it would be 4 for every 4 cups. We'll actually gain 3 centimeters. right? So we're adding to what we had before. If we want to think about it as maybe like a rate of change, so it's like over 1, we would get 4/3 of a centimeter for every 1 cup that goes in. So however you want to kind of look at it, but it really kind of makes it so this is how this picture actually changes, right? So at what point does your line intersect the vertical axis? Okay, remember the vertical axis. We can look at that, and then what do the coordinates of this point tell you about the cups? So we can actually go ahead and we can count those. So we have 1, 2, 3, 4, 5, 6. 6 is where that is. And so that point is 0, 6. So side to side is 0, going up and down is 6. Well, what does that really tell us? That tells us that we already have, that when we have a cup sitting there, it really kind of starts with the 6 centimeters. So if you think back as far as a cup and how the cup actually works, it actually has, so kind of like this, how the stacks of cups change. It's actually only adding a small amount apart onto it, and it's that lip of that cup. So you have to think about it. Okay, we have a cup. It's kind of sitting there. If we add another one, it's only going to add just a tiny, tiny bit on top of that. So that's why it doesn't start with 0, 0. It starts at 0, 6. So notice this is our stack of cups that we were working with before. You can actually look at this on page 46. And if you look at it, we have the top of this cup is 6 centimeters. So if we put down 1 cup, we're automatically going to have 6 centimeters. What does this graph actually show? It's actually showing that we only add this tiny little lip every time that we are adding a cup. So it's kind of what it's actually talking about, where we have this cup, but we're not looking at that 6 centimeters part. We're actually just looking at how much more will it go ahead and add onto it. So that's kind of what the 0, 6 actually represents. And then let's go ahead and let's answer question number 5. How much height does each cup after the first add to the stack? So the first one, again, we have that 6 plus the little lip, and then we're looking at the tiny little piece of that cup adding over and over and over again. So what is that? It's actually 4/3 centimeters. So remember our slope was this 4/3. If we take this and put it as a rate of change, so remember a rate of change is something over 1. We're going to take that amount, and it's going to be 4/3, and then kind of all of this over 1. So what it actually entails, and if we actually label this with, so pretty much this is our y over our x, and we actually label that piece of that information. Our y is the centimeters, and our x is the cups, or cup. So for every cup that we have, it adds 4/3 centimeters onto our stack that we're looking at. So again, here, kind of how it actually shows, if we really narrow into the information and zoom into our graph, we can actually see how here it's like 4/3. It's not just 1, it's a little bit more than 1. So 4/3 over 1 is that rate of change. And again, if we label it, it's 4/3 of a centimeter for every cup that is added to the stack. So today we've been talking about linear relationships and how if something is a linear relationship or if it's a linear relationship or a proportional relationship. A linear relationship is kind of what we've been working with today. A linear relationship is where it does not go through 0, 0. So a proportional relationship, we've been doing this for a while with all of our lessons lately. It goes through 0, 0. A linear relationship does not. That's kind of the difference between the two. Does the rate of change of a linear relationship, what does it tell us? It tells us the story. How does that line change from where do you actually begin? And the beginning, again, is not 0, 0. It's usually a number. And it can be a positive number, and it can also be a negative number. So again, here's some definitions that we've been going on forever. So the slope of a line, it is the vertical over the horizontal. So it's the vertical distance over the horizontal distance. We've been doing slope triangles, so we understand that. Awesome. Next is the rate of change. It's a linear relationship between two quantities, x and y. And so we're going to go into this a little bit more. This is a very mathematical definition, and part of it we haven't talked about yet. But a rate of change, again, is a unit over 1. And we talked about it today, was like 4 over 3 over 1 kind of thing. It's really kind of complicated, but it actually helps us with the information. And we're going to do more about a rate of change for a linear relationship in our next week. All right, go ahead and go back to page 135. So I got to change this. So it's 135. And give yourself a sentence about today. I can find the rate of change of a linear relationship, so that's a line that does not go through 0, 0, by figuring out the slope, right, slope triangles, of the line representing the relationship. Go ahead and give yourself a sentence and a number. So 1, I don't remember, or I don't get it. 2, I kind of get it. 3, I got it, but then 4, I can teach it to my friend. Give yourself a sentence and a number. Go ahead and make sure that you do your practice problems in Canvas. Go ahead and do your stuff in your workbook and then upload the answers into Canvas and make sure that is done. And then just as a reminder, tomorrow we do have a quiz. And the quiz is lessons 1 through 4. So we do have a quiz because it will be Friday. So have a good day, and I'll talk to you later. Bye.